Alright students, let's talk about position vector and displacement vector. Alright, well, vector analysis have their own notations. Like chemistry have their own notation, bio have their own notations, mathematics have their own notations. Similarly, we need to understand very clearly what are the notations used in vector analysis, and then only you will understand it perfectly. So let's say that this is my x-axis and this is my y-axis. Let's say I'm having a point P at some time t, and the point P moves in this path and it reaches point P dash at some time t dash. Obviously my interval is delta t, which is equal to t dash minus t. In this interval, the particle has gone from P to P dash. Beautiful. Now, by definition, what is a position vector? At point P, position vector is this. And what is a position vector? At point P dash, this is the position vector at point P dash. I'll represent position vector as R vector, which is, I can say, OP vector, and OP dash vector is R dash vector. Position vector simply tells what is the position of a particle with respect to time and with respect to this xy plane. Very right. Now, I can also write position vector R is equal to what? This position vector. Now, I'm not talking about these position vectors generally. Generally, in case, let's say there is a point P. Obviously, this point has its own coordinates x and y. So, this position vector at point P can be represented as what? X I cap plus y j cap, where x and y are the coordinates of the point. You might call them components, this x and this y component, or you can also say they are the coordinates of the point. Remember, guys, x and y are not vectors, but x multiplied by I cap, which is a unit vector in x direction, becomes a vector. You can also write this as x vector. You can also write this as y vector. All right, let's not go into so much details. So now I basically have understood that at point P, this is my position vector. At point P dash, this is my position vector R dash vector. Now I want to talk about what is the displacement vector. In very, very clear terms, displacement vector is basically the vector which indicates the displacement from initial position to final position. And as I talked about notation used in vector analysis, displacement vector is, we can write the displacement vector as delta R. It's a vector. Every vector, either you write it in a bold way, I cannot write, or you add an arrow on the top of it to show that it is a vector. If you have not added arrow, you have simply write delta R. This means the magnitude of the vector delta R. So these 2 points are very, very clear. Displacement vector delta R is basically defined as, we define it like the position vector indicating final position minus position vector indicating initial position. Very, very simple terms. Displacement vector from P to P dash, or for any object, any particle moving from one point to other point, the displacement vector is a vector which is difference of the vector which represents the position vector final position minus position vector at the initial position. To make it a little more elaborate, let's say point B is here, it goes here, 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 here. This is the initial position, this is the final position. Honestly speaking, this vector will be the displacement vector, which is connecting the initial and final position. All right. So now I'm going to go further. Now you see that how can I draw displacement vector? I'll draw displacement vector, not just draw, but also explain how it's there. Displacement vector is in this direction. And I write it as delta r vector. Now, let me apply triangle of vector addition to see how I got this direction. Well, I want to subtract r1 dash, I want to subtract r dash from r1 dash vector. All right, r1 dash vector here is positive, so I'll take r1 dash parallel to the same vector. This is r1 dash. Now r vector has minus sign. How can I have, how can I, if I add minus sign to a vector, what happens? Its magnitude remains same, but its direction reverses. And now I have to reverse this. At the same time, adjust this vector with this so that these two vectors together represent two sides of a triangle taken in the same order. And obviously, if I take parallel to, you see, I'm drawing with the hand, maybe I don't draw with so much accuracy. Initially, if you see this vector and this vector were same almost magnitude, but the direction was this, and that was r vector. But now I reverse the direction, it becomes minus r vector. Now minus r vector, now this is a vector. Now forget about minus sign. This is just a vector. Its name is minus r vector. So I'm basically adding them. Instead of subtracting r dash from r1 dash, which is a difficult process in vector addition, what I do? What I'm doing is I'm adding r dash vector and minus of r vector, and this is simple. This vector is my this vector and this, and according to triangle of vector addition, you see that very simple. This and this, the order is this taken in the opposite order. This would be, difference of two, delta r dash. You can even say someone also say this is a resultant of these two. And resultant is what? Basically, I'm subtracting this from this. That's why I say difference of this. Very well explained. So this is delta r vector. And now I go for analysis of this. All right. Give me 1 second. So, all right, delete this. I also delete this. Right. Now, so this is just for the explanation. I've drawn this, otherwise it doesn't have any relevance, just to tell you how its direction is like this. All right. So now if I say, now I can also extend it like this is equal to, now what is r dash vector? R dash vector is an independent vector. It has its this much component, that is r dash x, and it has its this much component, that is r dash y. Just a component, it's not a vector. But when I multiply r dash y with j cap, unit vector, it becomes a vector. Similarly, when I multiply r dash vector with I cap, it becomes a vector again. So similarly, this vector r also has its y component, that is ry, and it had its x component till here. So this is rx. This is rx, and this is r dash x. This is ry, and this is r dash y. Summarize in terms of them. So I say that r dash vector can be resolved into its x and y components. I can write r dash x I cap plus r dash y j cap. This completely represents this vector, right? Now minus, take this. What is r vector? That's again r x I cap plus r what? R y j cap. This is equal to this minus this minus this, because vector addition is cumulative. So it becomes r dash x minus r x into I cap plus r dash y minus r y into I cap. And guys, do you really understand what is this? These are, interestingly, I'll tell you, the x component of displacement vector. This is the x component of displacement vector, and this is y component of displacement vector multiplied by, I'm sorry, it should not be j I cap, it should be, I'm sorry, it should be j cap here. It should be, I did a mistake, I'm sorry, this should be j cap here. So this is j cap. Now, guys, you want to understand how. So basically, r dash is this vector, and r dash vector. Do you know this is basically r dash x minus r x? How? This thing, this complete distance minus this is this distance. This is r dash x minus rx. Hence, I say this is del rx. And what is del ry in this? Del ry, guys, you see, is basically this distance. How? I have basically subtracted ry from r dash y. So I am left with only this distance. A very simple mathematical problem a third class student can do. So this is delta ry. And now also some students sometimes end up asking, why not there's a minus sign here? It cannot be, because delta r, every vector, like every man has, uh, you know, you know, his man is destined to be married. Every woman is destined to be married. Similarly, every vector is destined to be resolved into its x and y component, and they have to be together. That's why delta Rx is equal to delta Rxi cap plus delta Ry j cap. Hence this. You can also write it like delta Rx vector. But this, if I multiply delta Rx with I cap, it becomes this vector. And it becomes this. This vector is basically delta Ry vector, this vector. And if you just talk about this distance, the magnitude, it is delta ry, that is r dash y minus ry plus delta ry vector. Thank you, guys. Do like our channel and see other videos on learncbsc.com, I'm sorry, not com, CBSC YouTube channel. Like it, share with other people. Thank you very much.